Here's a number that surprised me when I first heard it. The average American home has somewhere between 50 and 100 processors in it. Not 50 computers, 50 processors. They're in your thermostat, your microwave. Your car has dozens of them. Your washing machine probably has one. And that's just the stuff you own. The traffic lights on your commute, the elevator in your building, the card reader at the coffee shop, all running on small processors. Most of these aren't powerful chips. They're microcontrollers, tiny, cheap processors that do one job and do it reliably. But they're still processors. They still fetch instructions, execute them, and produce a result. The same basic idea that runs a billion-dollar data center also runs your toaster's timer. So what is a processor actually doing inside all these things? At its core, every processor does the same 3 steps, over and over, billions of times per second. Fetch an instruction, decode it, figure out what it's asking. Execute it, do the math, move the data, whatever the instruction says. Then grab the next one. That's it. Fetch, decode, execute. Whether it's rendering a video game at 120 frames per second or checking if your fridge door has been open too long, it's the same cycle. The difference is just how fast the processor runs it and how many instructions it can handle at once. A modern phone processor can execute several billion instructions per second. The chip in your microwave might handle a few million. Same principle, wildly different scale. You've probably heard the comparison before. Your phone is more powerful than the Apollo guidance computer. And it's true, but it doesn't really capture the scale. The Apollo guidance computer ran at about 2 megahertz, 2 million cycles per second. It had about 74 kilobytes of memory. That computer navigated astronauts to the moon, and it's genuinely impressive engineering. But a modern phone processor runs at roughly 3 gigahertz. That's 3 billion cycles per second, about 1,500 times faster, and it has millions of times more memory. The real point isn't just that phones are faster, it's that this much processing power became cheap enough and small enough to put in everyone's pocket. That's the part that changed the world. Not raw speed, accessibility. When powerful processors get cheap, they show up everywhere. And that's exactly what happened. Here's where it gets interesting. The processors you interact with directly, your phone, your laptop, those are actually a tiny fraction of the processors working for you. Every time you search something online, that request hits a data center. Rows and rows of servers, each packed with processors, crunching through your query and returning a result in a fraction of a second. Every time you stream a video, tap a payment terminal, or get a weather notification, processors in a building somewhere are doing work on your behalf. Cloud computing basically means renting someone else's processors. And the scale is enormous. The big cloud providers, Amazon, Google, Microsoft, they each operate millions of servers. That's billions of processor cores running around the clock, handling everything from email to AI training. You might use your phone's processor for a few hours a day. But the processors in data centers are working for you 24/7, even when your phone is in your pocket. So why should you care about any of this? Because the trend is only accelerating. Processors are getting more specialized. Your phone already has separate processors for different jobs. One for general computing, one for graphics, one for machine learning, one just for managing the camera. Cars are heading the same direction. Modern electric vehicles can have over 100 processors handling everything from battery management to driver assistance. And then there's AI. Every time you talk to a voice assistant or use a recommendation algorithm, that's running on processors, usually very specialized ones called GPUs or dedicated AI accelerators. The explosion in artificial intelligence over the past few years is fundamentally a story about processors getting powerful enough and cheap enough to run these workloads. The chips keep getting smaller, faster, and cheaper, and every time that happens, they show up in places they weren't before. That's been the pattern for 50 years, and there's no sign it's slowing down.